In this clip, I'm going to talk to you about Snell's law and how it is different from the versions of Snell's law that you've seen at GCSE. So you will be familiar, the first equation that you will be familiar with, or one of the equations you'll be familiar with from GCSE is n equals sine I over sine R. And I've mentioned this before to the classes that this is true, but it's only true, it's a special case and it's only true within certain circumstances. So the circumstances about which that is true, that equation from GCSE is true, is when you are going, or when the light or the ray is going from air, which we approximate to having a refractive index of 1, so we have it going from air into a material which has a refractive index greater than 1. So typically materials such as plastic or glass, which are materials which are used in a number of applications, a number of optical applications. So there we might have something like glass where it's 1.4. So in those situations, that equation is true. However, we cannot use that equation in this other case. And at GCSE, the other scenario that we might look at, generally related to total internal reflection, is if you have light incident on a boundary, but effectively going in the opposite direction. So I'm going to draw it in the opposite direction to try and help make my point. So the light is coming from the material that's more optically dense. More optically dense means refractive index greater than 1. And then the light will speed up, it will refract away from the normal, and it will do something like that. Now, in this situation, you can't use any sine I over sine R because it's not true. However, if we wanted to find the critical angle for this situation, we can use this equation. So n is 1 over sine C, where C is the critical angle. And in this situation, if we have this refractive index of 1.4 and we have n is 1 here, then what we can say is that we can rearrange this to get sine C is 1 over n, so 1 over 1.4, and then all we need to do is to calculator, we can do 1 divided by 1.4, and then we can do the inverse sine of that value, which gives us 45.6 degrees. So it's a 3 sig fig. So we can use that equation in this situation, but we can't just cross between the two. And at A level, we have a more sophisticated, more general version of the equation that works in both situations, which is given as this. So the more general formula is n1 sine theta 1 equals n2 sine theta 2. And generally, to help you understand and follow what's going on, then you would have this as your incidence, your angle of incidence. Doesn't matter, but I would generally advise that this is the first material and this is the first angle, so that would be your angle of incidence. And this is your first material, and the light is going to the refractive index of the second material. So that would be your angle of refraction. It'll still work if you swap them around, but it can get confusing.